really quick, like 15 minutes tutorial on how to create a cage of like a lattice system. So first, I want to show you what is looks like at the end. So there's many ways you can do it. You can make it as a very organic, blobby shape like this, right? You can also make it looks like more rigid, kind of like a rectilinear fashion. So they both works. You do need to think about what is the purpose, right? In the future, if you really want to push this into a real-time rendering engine, like Unreal or Twinmotion, the number of polygons does matter. So keep in mind, if you go with a really smooth organic shape, this maybe have millions of triangles. This could be a slow render. But if you want something more rigid, this is based on the rectangular shape, this is much faster to be handled in real time. Okay, so I will do a really quick demo how to do this with just basic Rhino. So first, if you recall, last time we create this sub-D model, right? Then we convert sub-D into quad mesh. So we did this through the mesh, the sub-D tools. There's a command here. It's called quad mesh, right here, right? Quad remesh. So basically, you can see the geometry of the quad remesh is really clean. It gives you the very evenly distributed points. What I mean is the density of these lines is very even. Okay. However, if you don't use a quad mesh, if you just directly say mesh, I'll show you really quick. So this is the sub-D model. If I just type mesh, Rhino has a default way to translate sub-D into mesh. And you can control the density of the points, the polygons. Click OK. You can get exactly the same kind of, not exactly, the same result, right, the mesh. But if you really compare the tessellation, right, of this mesh with the quad remesh, you can see the geometry is not evenly distributed. Right? The points in some area is really dense, but in some area is really loose. This really depends on the curvature and the level of details. So they are quite different style. So it depends on how you want to control the final outcome. You maybe sometimes you want to choose mesh rather than a remesh. See the difference? Right. So one is evenly distributed, another is not. Okay, so this is the first thing. Then let's think about how we can create a cage system. Okay, so in Rhino, if you are a beginner, you probably heard about there's a command called pipe, right? You can pipe a curve into 3 dimensions. So for example, if I have a curve, if I just type pipe, I can control the radius, enter finish, then you can create a pipe. But this could be an issue since this is based on a NURB surface. It's pretty complicated with a lot of control points. If you imagine I want to create a pipe for the entire model, the computer is going to crash. Right? So let's just do a quick demo though. So for example, I really like this quad mesh, right? I want to do a pipe, which is dangerous, right? So first I will type a command called extract wire mesh. This is the command is really useful. You guys should remember it. Extract wire mesh. So if I do it, well, this one gives me a warning because this is already beyond the computing power. It's beyond 10,000. So that's no. But you can see it does create a mesh, but this is not a good idea. This is gonna be too dense, right? It is curved. If I zoom in, they are curves, right? So now if I do a pipe, it will crash, but I will just do a small piece of it. So if I do a pipe, I will just give a diameter as, I don't know, 10 maybe. right? You have this result. I think 10 is too big. Let's do a smaller one. Maybe 1. Okay, so you got a pipe. All right, so this is the default Rhino way. I just create a lattice system. I wouldn't recommend this approach. Just make the file really big, right? You might also wonder, if I undo this, what about the multi-pipe, right? If you recall, last class I showed you can do a sub-D multi-pipe, right? So you can actually try it. If I choose this group of curve and I create a multi-pipe, radius that's using 1, enter. Cap ends, I will just choose off. Division 1 is fine. I will give 0. I want to have a smooth version. All right, so this is a sub-D version of cage, right? And compared to the pipe, can you guys tell the difference? Maybe you don't recall what the pipe looks like, right? But this is a sub-D pipe, or the sub-D multi-pipe. So what's the difference is the intersection. And here is the intent to merge all the pipe together. So you have this kind of smooth transition in between. Okay? So is this a good approach if you want to do real-time rendering? Any thoughts? Probably not, right? This will require a lot of geometries, a lot of mesh triangles to keep the smoothness. So this will slow down the rendering as well. But it could be really cool. Depends. Maybe part of your building could have this fashion, right? Okay. So I will undo this. So this is the multi-pipe with sub-D. Then I will show you another approach. So this approach is actually use Grasshopper to do it. So Grasshopper, if you recall, I showed you there's a plugin called Wavebird, right? Wavebird allow you to take a mesh geometry. You can create a frame, right? And then you can create a thickness. And after that, you can create a smooth, right? In this case, because I want to keep everything as a minimum, so I will change the smoothness level from 1 to 0. Right? So basically, you just create a rigid frame. Or you can just get rid of this part. That's the part I did last time. So it's only take a mesh geometry, create a frame window, then you create a thickness. Okay, so this is only 3 steps. So here, let me try. I'm not gonna using the wire mesh. It's not needed anymore. So I will just take a mesh geometry. So let's say, do I have a cleaned version? What's the version I just created? Yeah, so this is a mesh, right? So I will take this mesh in. It's maybe gonna take some time to compute. Right. So once you take the mesh in, it's automatically pushed through this process. So if I turn on the draw preview, I can see first step is create a window. Second step, create a thickness. So if I hide the original one. Right, so this is the kind of final version. Maybe let me just bake it. Level 5. Okay, so this is the Wavebird approach. Right. It's really low poly. If you tell the triangles, right, this is a straight triangle. There's no smoothness involved. So I really like this approach instead of doing the multi-pipe or the Rhino pipe. I think this one gives you a much efficient cage geometry. Okay, if you really like the smoothness, you can still do the Wavebird. For example, you can create the subdivision in Wavebird. You can drag in the geometry. if the default level is 1, is kind of smooth, but you can also increase this to 2. If you bake it, it sort of gives you the multi-pipe style. Right? So if I show you the full one, right, you see this polygon number is much higher, right? But it looks a little bit smoother. Okay? In the rendered view, you can tell the difference. Okay. So this is the Wavebird approach. In my old tutorial, I also covered a few other approach. Just watch it. There's a different Grasshopper script I shared in this tutorial. It's basically from my earlier Grasshopper script, but you can just simply feed in the lines, the individual lines, and then you create this kind of pipe. But it's a rectangular profile. It's not a circle profile. Okay, so I don't repeat here. All right. Yeah, I think that's pretty much about the only thing I want to show you today. Mesh, right, versus quad mesh. So mesh is not evenly distributed. Quad mesh is pretty even. Wavebird, we covered a little bit extract wire mesh. Pipe versus multi-pipe. By the way, I think for the wire mesh, just switch here. So if you do have, for example, a mesh version of it, wire mesh, extract wire mesh. Oops. Extract wire mesh. Oh, sorry, this is a sub D. I forgot to do that. So you have to convert to a mesh first, right? Yeah, you have to convert to a mesh first. Then you can do extract wire mesh. This is a mesh. Extract. Oh, extract wireframe. Sorry, keep saying the wrong term. Extract wireframe, right? So you have this. I think that's pretty much. And also, if you make a selection, right? Rhino always tell you how many objects in your selection. So here you have 6,300 curves. So you should be aware if you do a pipe now, this could be dangerous. I don't know. Let's try. You see, it takes a long time to compute. Actually, it's not too bad. It might be because my computer is fast. I have a really good GPU. But this is a pipe version of it. Cool. Any questions about this approach, Cage? I do have a few other approaches using 3ds Max or even Rhino or even Revit. So I'm not covered here in this tutorial. But if you're interested, you can check my Revit or 3ds Max tutorial library. You can find a very similar kind of result, but use different tools.